Definitely works. Okay, hey everyone, welcome to the next set of talks. So we have Tuana talking about everything is a graph, including LLM applications, and that's handy. Give a round of applause. So she'll be taking questions at the end of the talk, and there are some special goodies for some good questions. So please pay attention and keep them coming. All right? Thank you. Over to you.
Thank you. All right, yes, it does work. No questions here either. All right, thank you very much, everyone, for coming to this talk. I do realize that this title is a bit of a bold statement, but hopefully by the end of this talk, I've been able to convey a certain approach that we've been taking to building AI applications. LLM applications, yes, but also just generally AI applications. A bit about myself before I jump in. My name is Tuana Celik. I'm actually from Istanbul. I live in Amsterdam. And I work for a company called DeepSet, and we have a fully open source AI framework called Haystack. And I'm going to try to make it so that in this presentation, I'm not necessarily diving into a lot of AI theory, but hopefully I can convey a broad understanding of how we approach AI applications with Haystack, and hopefully you start to build some of your own as well. Bit of forewarning, there is a lot of Taylor Swift reference in this presentation, so if you don't like her, that's too bad. All right, so I'm going to start off by explaining how, in my opinion, the way we build AI applications and the way we interact with large language models has come into a new era, guys. And the reason I think that is the way we interact and the responses we get from AI applications seemingly feel like they can grant us anything, they can do anything. And my perception of why this is or how this has come about is because something changed in 2022. Now, this is not to say that generative models didn't exist before 2022. They very much did, actually. But we realized something quite important with the way we interact with these language models around 2022 when ChatGPT was released. While previously we had AI models very specific to use cases, so if anyone's familiar with Hugging Face, you can go onto Hugging Face and you'll see summarizer models, translator models, extractive QA models. And these models were able to work in some way. We started to realize that with quite performant large language models, the way we interact is quite different in that we start to instruct them. So models themselves have become somewhat chameleons. I can have an application that does question answering simply by instructing it to do question answering. I can have an application that does summarization, question generation, translation, and honestly, this list can go on and on and on. So I want to jump into talking about one of the most, I'm sure a lot of you have heard the terminology retrieval-augmented generation. So I'm going to start talking about how that comes about. So the idea is, let's say we have a database that's holding some amount of information. That database can be one of many things. And let's say we want to achieve an application such as question answering. That instruction to a model could be like the following. Given the documents, answer the question. And then there's some stuff to fill in. So the way these applications actually work, and honestly, a lot of model applications like ChatGPT in the background also often work like this too, is ideally there's a query, and from the database we are able to extract the most relevant document to that query. And then we want to augment our instruction with the contents of that document, and then the LLM actually has something to work with. Large language models are trained up until a certain point in time. They're very performant, they're very good at their job, but that doesn't mean that they know all of the information that you need to be able to achieve correct results. So if you take a step back and look at those steps that we just went through, we actually have two major steps going on in this type of application. We've got the retrieval step, where we're extracting the most relevant information, followed by some sort of generation step. And honestly, The point I'm trying to make here is it really doesn't matter what model you use or what database you use. It's just the fact that there are these two tasks that are forwarding information one to the other. Okay, so this was a very popular one. I'm just going to put that aside, and let's maybe think about something maybe a bit more boring, but it's still very useful. Let's talk about embedding text data into a database. Now, for anyone who doesn't know what embedding means, I'm going to quickly just mention the fact that embedding data just simply means representing data in vector form. This is quite useful for semantic search to compare the similarity of one vector, text, to another. But let's say we need to embed some data and we need to write that into a store somewhere. You may start with just raw documents. Maybe you need to do some cleaning. Maybe there's just stuff there that you don't need. And then, let's be honest, although there are models out there now that have pretty impressive context sizes, maybe you need to do some splitting up. Maybe it's just not possible to add all of your data into your prompt. And then let's say, again, you're going to embed all of those splits, and then you're going to write them into a database. Now, again, if you take a step back, you'll notice that all of this is small tasks, small things that have to be achieved, and data has to go to the next task, to the next task, to the next task, and the next task. So maybe you already start to notice that this is starting to look like a graph. And maybe it's actually quite useful if that graph can do some cooler things, like branching out. I can give you a very simple example of why branching out might make a lot of sense. For example, let's say you have information flowing in to your graph, and you have TXT and PDF files, and you have to do something with them. And maybe you need to pre-process them in different ways. Maybe I don't need to have a completely separate process going because I'm going to do the same thing with the resulting data. But maybe it makes sense that I can branch out, pre-process them in their own way, and then write them into a database with their embeddings. That's just an example. So this is where I start talking a bit more about Haystack. So there is a bit of Haystack terminology. But like I said, that QR code takes you to our GitHub repository. But Haystack, it was first released in 2020, actually. And in 2020, the main NLP tasks that were being covered were all around retrieval and semantic search and extractive QA. And this concept, this idea that NLP or AI tasks can be covered being represented as a graph was there when we first released Haystack 1.0. But then, with the rise of very performant large language models, prompt engineering, we noticed that we had to make our pipelines a lot more performant, and maybe it actually makes sense that pipelines are not acyclic anymore, that they can cycle. And one very good example of this is, what if I have a task where I have to continue trying if something is wrong? An LLM is still an LLM. We're still generating responses. I'm going to show you an example of this in action later on, but maybe it makes sense to have these pipelines effectively become a service that can repeat itself until a certain correct result has been reached. This is just an example of a use case of a cycling graph, but there are plenty more. So we released Haystack 2.0, and we kept the fundamentals of Haystack 1, which was to create a very performant AI application. We're going to approach this as a graph, and that graph we're going to be calling them pipelines. And pipelines consist of components, each responsible of one particular task, and forwarding the results of that task to the next, to the next, to the next, until you reach a result. I'm going to start with the most basic part of that graph, the component. I'm going to give you an example of a component because although Haystack provides a bunch of components, you can go ahead and create your own. And what you're seeing here is a very valid component. We simply have a class. This is a node in the graph. We simply have a class with a component decorator, a run method that expects any given number of inputs. So in this case, it's input 1 and input 2. And it returns a dictionary of results. In this case, it just returns output. This is a very valid node in a Haystack graph. So here's my dummy translator graph. Let's assume I need to do some translation to any incoming documents. I have a component. It has a run method that accepts three things: from lang, to lang, and documents. And then hopefully it's doing some level of translation and then is outputting the translated documents. How do I combine these components? How do I build out my own graph? And here is an example of two components attached to each other. And it's important to know that the type that one of them is outputting is also the type that the next is expecting as input. So here I have an example. The first one is expecting a sentence. Is Taylor Swift queen of the world? And it's producing a vector representation of that sentence. Let's call this an embedder. We actually do have embedder components in Haystack. The next one is expecting a vector, and it's producing a document. So presumably what this is doing is comparing the sentence to all of the other documents in the vector space and saying, here's the most relevant document to you. So if I've done this, I've pretty much achieved a good document search pipeline. The next thing I want to talk about is how the fact that these pipelines can then cycle means that we can effectively achieve what we are now calling agentic pipelines. I'm sure a lot of you have heard the term agents being thrown around a lot. Effectively, this is a component, a large language model, a model, whatever you want to call it, that has been given the duty of deciding what branch of this graph to invoke, depending on what the task at hand is. So for example, in this scenario, I may have an agent that says, oh, the incoming task requires me to write data into a database. I should invoke the pipeline down on the left branch. Another task may say, oh, I need to do some question answering. The incoming thing is a question. So I need to invoke the pipeline down the middle, and then so on. The example on the right-hand side is, I don't actually have any information in my database about this. I should be doing web search. And this is where you'll see references to agents with tools describing what they are most useful for. And we've actually noticed that this is actually quite possible by approaching this whole thing as a graph in itself. Quickly about Haystack, we do have a bunch of components that are built the exact same way I just showed you. They can be generators, embedders, classifiers, rankers, the whole lot. But the point isn't that this is a finished product and you can go ahead and create your own pipelines. Actually, pretty frequently, we maybe haven't had the creativity to go ahead and create a component that you need for your own use case. This happens quite often. So what we see is people creating their own components, maybe packaging them and making them available to the community. I've done this myself. For example, we do not have a Mastodon fetcher. I wanted to do some sort of RAG and question answering on Mastodon usernames. I create a very small light-level component, and I can package it and make that available to the community. So now I'm actually going to start trying to build a pipeline with you, and this is going to be a web QA pipeline. I'm going to try to switch to Colab and hopefully do some level of coding. I hope it works out. I'm hoping the internet works. So for this example, what we're going to be doing is we're using 4 components. The first thing is going to be expecting a URL, or URLs actually. We're going to be fetching that content. This component is only responsible for fetching content. The next thing is going to be converting that into a format that is actually usable by our pipeline. Next, we're going to be creating an instruction. In the Haystack world, this is called prompt building. I'll show you how that works. And then following that, we have a generator component. And here, we're going to have many options as to what model we actually use. So here, we start creating our web QA application. You can see that the first thing I'm doing is I'm creating my components. And the one thing that's kind of very much Haystack specific here is the fact that for our prompts, we're using Ginger templating. So this is effectively making documents and query inputs to my prompt builder, because documents is going to come from one node, and query is probably going to come from a user. And we're going to be looping through each document, and we're going to be adding the content straight there into our prompt. The next thing we do is we add these components to a pipeline. That's easy. We give them names. And then following that, we're going to be connecting, and this is where things can get very verbose and you can build quite complex pipelines. We're going to be connecting these components to each other, specifically in the way we want to see our graph interact with itself. The next thing we can do if we want, and I think this is quite a neat way of checking that your pipeline is actually doing the thing you expect it to do, you can .show your entire graph and check that the connections are what you would expect them to be, and that you know what kind of inputs each component is expecting. So I went ahead and did this. I recorded it just in case it wouldn't work, so let's see if it does work. Hopefully this is working fine. I have my WebRag pipeline here. I'm going to run it. I'm asking it to fetch the contents of our quick start. This is just a page on our website. And the question is, which components do I need for a RAG pipeline? Let's see if this is going to work now. And if this does, the next will also work. And there you have it. We have a result for this. I want to go back and show you something where what happens when I break this pipeline, because there's actually quite a useful thing in terms of understanding how the graph is being built and how the components are connected to each other. So I'm breaking this by not giving the LLM the prompt. I'm just going to try and attempt to give the large language model the converted files. And you're going to get an error. And we've got a pipeline connection error, because here we're being told, hold on, this connection in this graph is not possible. The converter is outputting documents, which is a list of documents, and this node is expecting either a prompt, which is a string, or generation quarks, which is optional. This is quite handy, because then you can figure out whether you've done something wrong and how exactly to fix it. If I do have a correct connection, then I can validate that it's happening, the connections are what I expect it to be, basically. All right, let's go to the next one. This is another one that we built. This is yet another graph. This is called the Hacker News Summaries, or Hacker News TLDR pipeline. This is completely available on Hugging Face. You can go ahead and scan that QR code. It takes you to a working Hugging Face space. This is completely built with Streamlit. If anyone hasn't used Streamlit yet, would highly recommend. It makes it super easy to have nice UIs up. And the idea behind this pipeline was, I just want to have a slider. I want to select a number. And I want to get summaries of that many of the current trending Hacker News articles. This is a screenshot of me running this yesterday evening, I believe. And I just simply asked for the top two trending articles at the time, and I got a result. Now, do we have a Hacker News fetcher for Haystack? No. So what I had to build was a pipeline where the green ones you can see here are already available. Fine, I can just use that out of the box. But Hacker News Fetcher is not something that's available, so I have to create that myself. And this whole thing is supposed to accept top K number, and is supposed to produce summaries. And then let's have a look at how that works. I can actually try run this now. If anyone uses this now, I am sorry. I think I broke the Mistral generator, but the OpenAI one should work. You just have to provide your key, and maybe someone can validate that this is actually the top trending news article on Hacker News now. But it should print out a summary and a URL too. The reason it's able to print out the URL is because that is exactly how I built my prompt template. I built a Hacker News fetcher myself. I hope this is large enough. I can make it a bit bigger. That is a class with a component decorator, expects top K. But what I do is I create Haystack documents, but I also add the URL from which the contents of this article is coming from, which makes them accessible to my prompt builder. So when I'm augmenting my prompt, I can also add the URLs of each document or each Hacker News article, and then I can simply have my instruction be, please summarize this article and reference the URL that you see right after it. All right, let's go to the next. The next thing is a Notion QA graph or pipeline, if you will. This is my own Notion page. It's just containing an article about how to build custom components and the various things that you need to build it. It's my own private Notion page. Again, this time the problem was slightly different. We actually had a great community contribution for a Notion extractor. Unfortunately, that Notion extractor was only for Haystack 1.x. So the only thing that we had to do in this case was to export that, convert it to a component that is available to Haystack 2.0. I'm hoping this works now. I think I should have my API keys here as well. And next, I'm just going to go ahead and create my pipeline, where this time, instead of using anything else, I'm going to be using my own exporter, the Notion exporter, as the first node of that pipeline. So hopefully I can run this. Great. Let's also print it out. Let's show the RAG pipeline. And there we are. And here we have it. So the first thing that this graph is expecting is page IDs. There's an absolutely crazy way of getting your Notion page IDs, so I'm not going to go through that, but you can find them, I promise you. And then it's going to be converting those to the Haystack documents, adding them to my prompt, and then generating a response. In this case, I'm also going to use the Cohere generator instead of OpenAI. Previously, I had used OpenAI. I can just switcheroo that and use a Cohere generator if I so wish to. And then let's run this. And I'm just asking, what are the steps for creating a custom component? And hopefully this runs, and you're going to get a response. And it's giving me a response with steps, which is really nice. But let's say I want to just change the task entirely. Summarize the following documents. And let's try that. I'm not going to show it. I think we can just go on. And hopefully that just prints out a summary instead. And hopefully it doesn't take too long. All right, maybe I'll come back to that. Okay. I'm not going to go through the entire code base of achieving this type of pipeline, but I just wanted to highlight when and how looping pipelines become really effective. So again, this QR code will actually take you to the tutorial, and you can run this entire code and generate structured outputs yourself. But for example, let's say you have a completely unstructured set of documents, let's say meeting notes, and you want to extract some sort of structured data out of that. And in most cases, you're going to actually have quite a few requirements around what that structured output is. It's going to have to follow a certain JSON schema, maybe. So in this particular use case, what we did is we have a Pydantic model. So we describe exactly what our output should look like, and we have our meeting notes. Now, the first two steps is just like any other retrieval augmentation pipeline on the surface. We just say to a model, hey, here's structured data, here's the Pydantic model, generate some structured output. That's not to say that this is going to generate the right type of output on the first go. So what we discovered was, yes, it doesn't necessarily produce structured output on the first go, But if we're able to provide the same model with the same instruction, not only our JSON schema, but also the error it got trying it the first time round, we are allowing it to try again, and we can loop through this pipeline over and over again by describing what the error it got from Pydantic was until it got to the right, correct answer. Again, output validator is not something that the project provides out the box, but you can just go ahead and build it. And in this case, we built it for Pydantic, but I'm sure you can build it for many other types of applications. The final thing I want to show, hopefully, okay, so we did get quite a long summary actually here. The next thing I want to show is yet another demo that is up on Hugging Face if you're interested. But this actually is 3 completely separate graphs working together. So this is AutoQuizzer. It was built by one of our colleagues just a few days ago, actually. And the idea here is that we want to be able to get the contents of a web page and create a quiz out of it. So we went ahead and created a quiz generating component. We can try it out. This is using Llama 3 with Grok. And I think if the internet works well, this is a web page about capybaras. And we have many, we have like 5 questions here, and you can try them out yourself. I actually have no idea. Let's just make up some answers. And you can submit that. And then you get a score for your results. But we can actually have 2 separate pipelines where we are asking the model itself to solve the quiz it created itself. So if we have the large language model play, given good internet, I think we're going to have to do this from the start. Let's generate the quiz. Let's answer the questions. And let's submit it. OK, I got 20%. No, oh, there we are. OK, so we have 2 options. We can either have a very, very simple pipeline running that is simply querying the model itself. So there's nothing really, no component behind this generator component. So it's like a closed book exam. In this case, we're completely relying on the internal knowledge base of the model itself. The next thing we can do, which hopefully either gets as good as this score, or it does better because it's able to do retrieval augmentation based off of the web, we're allowing the pipeline to first extract data and information about capybaras, hopefully, from the web, and then the model is answering based on that. In this case, apparently the model knew as much as it would have based on web information. And with that, I hope you build your own pipelines. We've been seeing people build quite complex pipelines, actually. And I hope you don't rely on everything that we've provided, but you switch them up with maybe components that are very unique to your use case. I certainly have been nearly exclusively building pipelines that have some custom components in there. And with that, thank you very much, and I'm happy to take questions. Yes?
So if you have a validator, one of the thoughts that come to mind is the failures and also successes go back in to train the model to do better. Is that a common?
Yeah, sometimes. In this case, we didn't do that because actually the model that we were using in this case was quite performant in deciphering what the error message was actually trying to tell it. And our use case, let's be honest, this is kind of a toy use case. And we had, Pydantic with kind of a simple Pydantic model. And I believe in the tutorial we used GPT-4, and GPT-4 did get it wrong many times, but once you hand over the error from Pydantic, it was actually quite good at correcting itself. So I think it will depend on the model. In some cases, I think you would maybe have to retrain, but in some cases not. Yeah. Any other questions? Yes.
So it's been my experience that if you have really complex use cases, that with the cycle and handing it off to LLMs, that there can be three problems. We'll have 2 out of 3 of them right, and you'll ask it, show it the error, and it will fix the third one, but then break one of the earlier two, and you sort of get into an infinite loop.
Yeah, that can be possible. So honestly, for the most part, which is why I think approaching them as these types of pipelines where there are very specific components that are responsible of tiny things, really, makes a lot more sense, because often we see, yes, large language models are great, but sometimes you just don't need them. Maybe the task is simple enough that you should be offloading that duty from a large language model, and maybe it should just be simply going to a classifier or a translator instead of relying on an LLM to do all of these types of tasks. And then the other thing is deciding when it makes sense to just have completely separate applications running rather than having a huge, huge pipeline that has many branches. So again, I think it depends on the use case and what kind of tasks you're dealing with. Yes, yes. So you can always have a component that is using a large language model, but then I believe actually in the AutoQuizzer there is exactly a component like this. But that component that then is assigning that output of a large language model to an actual component output, in which case that can be forwarded either back to itself or back to something else. Literally the only thing that you would need in this Haystack world, although I'm talking about Haystack a lot, but mainly it's about the idea of building these types of components and graphs. The only thing you would need is to make sure that there is an output that can be referred to of that component, and that the types match for the whatever next is coming. Yes, I think I see one there.
Yeah, I had a quick question on, let's say I was running a pipeline on, say, a photo album, and it failed halfway through. Do I need to track how much of the photo album it gets through, or do the pipelines, is there any assistance from the pipeline framework that would help me know how far it got if I restarted it or something like that?
Is this about, so I think you mentioned photo album?
It's an example use case. So like, let's say I had a database of photos or something, and I want to run some sort of job on it, and I also want to use an LLM to maybe get descriptive names for the photos or something like that. Yeah, does it help me with any sort of notion of progress through a data set, or is that something outside of the framework?
Yeah, I realized I actually didn't run any type of, we call them indexing pipelines. I didn't run any of those types of pipelines, but number one, the output is always the number of documents or photos that were written. There's also a progress bar, and if, let's say, any component isn't doing the exact thing you need it to, honestly, you can just wrap it up in another component class and make it do what you want it to do. Yeah. Yes. Right. I don't think I see any other hands, but I'll be around if anyone has any other questions. I think I'm going to head right outdoors, and I'll hang around there. So thank you very much. Hope you enjoy the rest of the conference.